Lecture 34, the last lecture before the final review. So let's see. We're going to talk a little bit about debugging and profiling code. First of all, debugging. If you're using something like VS Code, there is a debugger built into it, which works with things like the C# and the languages built into VS Code. It's usually pretty good. Probably the exception to that is VS Code works really well with Go, but the debugger is really horrible with that language. So you need a special dedicated debugger for Go if you're using that. Now, debugging and profiling code. What is debugging? You've got some idea inside your head of what the code is supposed to do. Let's call that A. But the computer is the ultimate literalist. When you put in your program isn't A, it's more like B. And then you run the program, and guess what? It doesn't do what's in your head, it does B. Every time. So debugging is getting it to that point where it does what you expect. Now, there's another kind of debugging, which is, you didn't meet the requirements. The idea you had in your head for A wasn't what you really needed to do. Lots of times you get to the point where your program does A and you go, no, that isn't what I want, okay, because my idea was wrong. But generally that's where you start, is there's this friction, this mismatch between what your idea is and what the code is doing. So that is debugging. And interestingly enough, as programmers, you're probably going to spend a large portion of your time doing that activity. I mean, there's meetings and there's other things you do and there's design and stuff like that. But when it really comes to coding, probably 90% of your time is not writing the code. It's fixing the code so it does what you wanted, not what you put in. So I'm going to talk a little bit about old school. And the reason that I generally start here is because when I'm debugging, I've used all sorts of debuggers, but on a day-to-day basis, generally speaking, I get along better with this, and there are some reasons why it works better under some circumstances. Now, if I'm trying to build some complicated algorithm, I want to build a B+ tree. And it's a complicated algorithm. It's an ugly algorithm to build. I've built one. It takes thousands of lines of code, and it's hard to build. And I'm in there trying to figure out what is this piece of code doing that I'm not expecting. There is the new school, which is debuggers, and they can be quite useful. But on a general day-to-day basis, I'm more likely to stick to the simple stuff, which is I'm going to try to get some output out of my program and see what it's doing. Because if I know I go partway through the code and it's right, and then I do a little bit more and I get that to be right, eventually I get to the bottom and I've gotten it to work. So I start out at the top and I go, what is my expectation to this point in the code? Add some print statements, see if that expectation is met. Go a little farther, add some more print statements. This works at the level of hardware. When I've got a piece of hardware that I put together that I'm trying to get it to do something, sometimes I'll add an LED. Does the little green LED turn green at this point? That means something. There's a 1-bit output. Or use a 7-segment display. But in any case, the idea is get some output out of whatever machine or piece of software you're trying to do and see if it meets your expectations. Now, you can turn this into more sophisticated things where it saves very specific information. It's quite common to collect this information into things like log files. Now, there's good motivation for this. Many years ago when I was working at IBM, one of the things we did is a study on the effectiveness of logging, because we knew that having stuff logged to log files in programs used up between 1% and 2% of the entire compute time of the program. So the question is, should you take it out to make the program faster? And 1 or 2% doesn't sound like much, but it uses up space, and it uses up time, and it takes time to code and maintain these things, sending stuff out to log files. Well, it turns out that we started tracing defects, and we found that when logging was turned on, the average amount of time it took a customer defect to get fixed once it had been assigned to a development team was 16 days of man labor. The average, if logging was turned on and we did some specific logging we were talking about, I'll tell you what, was 4 hours or 1/2 day. So it was 32 times as fast if we had logging on as if we didn't. And that kind of ended the argument about taking out logging, because fixing the problems is worth way more than 1 or 2% in the code. So let me give you an example of what I mean by fancy logging. I have a product I wrote some years ago. I still maintain it. Most of the customers do not speak English. Okay, it is halfway around the world, running on servers in Tokyo. And I'm not the sole owner of it, but periodically I end up doing some of the maintenance on this product. And, every once in a while, one of the customers has a problem. Okay, the simple stuff gets handled by the people that I built the product for, but some of the stuff requires code changes, and I want to be able to see what the user is doing. So I have actually a standard form that they know that if they're going to send me stuff to work on, they send out this standard thing to the users, and by now my users out there have seen this before if they've ever had a problem, where you go in the menu, you put in some information, and they send them this UUID, this unique ID. And you turn on some flags that are on this page, so you check some boxes. And I'll tell them which boxes I want checked when I see there's a problem. And this turns on some debug flags in the code. And then they go and demonstrate in there what's wrong, okay? And no doubt it's in Japanese, so I have to use Google Translate to translate whatever it is into something I can read. But at the end of this, okay, I get an email that says, yeah, there's this problem, okay, and here's the UUID. And then I turn around and I go look in the log files for that UUID. And all the messages, all the interaction with the server, all of the back-end stuff, lots of stuff in the database gets updated with that ID. So I can now follow through everything that they did and happened and how they got to the problem. And you think that helps in fixing the problem? You bet it does. Man, let me tell you, you can go through that. And now I've actually built stuff that I can take the application and I can put in that UUID and I can rerun what they ran, and it will click off about once a second each little thing that happened in the program, and each little page comes up, and I can go right to where they had the problem. And that's the power of really sophisticated logging, where you can actually trace through a program and see what happened. What are the advantages of this kind of debugging? It's simple. Most languages have the ability to do output, although every once in a while I run into one that really doesn't, and I find it incredibly annoying to have to debug by thinking instead of debug by testing. It works in all sorts of environments. Everything from I loaded a new program onto my neighbor's camera in their yard, okay, and I get output from it, to I'm working on something on my Macintosh, or I'm working on something on a full-fledged server. And it works remotely. Quite often the way that I get this output is not directly. I might have something on a client side that every time it does output, it turns this output into a message that it sends off to some other server that's logging what the information is so that I can see it. When you get this and you've got a whole file of it, you can look through it multiple times. Sometimes it's not the first time that you look, it's the 5th or 6th. You go down to the bottom and go, okay, I see there's an error here. Let's go back up above this and let's look at what's happening before it. And let's go back and let's go back. Okay, let's look through it again. And you look through it multiple times. That ability to look through a log file multiple times or a set of output multiple times is hugely valuable. This is one that most people don't think about. But if you build this stuff into your code to trace what it's doing, and you can turn it on and off, it's permanent. One of the disadvantages of an interactive debugger is when you exit the debug section, by and large, all that work that you just put in to find something is gone. And here's one that most people really don't think about. It leaves a residual trace of the amount of effort you put in debugging something. Over the years, I have found that most of my code, I'm a decent programmer, not spectacular, but decent. Most of it works fairly well on the first try. I write the code, I'm going along. And then every once in a while, I come to a section of code that just is hard. And it's just loaded with debugging print statements. And later, when I get it to work, what I do is I go looking for the debugging print statements. And the pieces of code that have lots of them in it, I write tools to go analyze this, are also the pieces of code that probably still have problems in it. So those are the ones that I go add more tests and go back to the original design and reevaluate and refactor and rework and work through, sometimes many times, because I have this indication that there is something wrong in this area, that I didn't understand what I was supposed to do, that I didn't get it right. So there's this residual trace. So tricks for print statement-based debugging and log files. The first one I'd say is add line numbers, and if possible, don't just add line numbers. You can also add what the file is that this print statement is coming from. And that will help tremendously, especially if you have things that are similar. You want to make clear print statements that explain what it is you're printing out and say where it is, because that where it is really valuable in terms of going, okay, go look at this piece of code and go, oh, there's the print statements and the values. And you ask questions like, how did I ever get to this piece of code? If you just get the print statement, you're going, that's odd. Where is that piece of code? So this removes the where and you get to why instead, and that's a much more valuable thing. And in C or C++, you can use printf like this to do that. There's also an __ file __, not just the underscore line. So you can print out the file and line number. You can use those with the underscore things like this, with the standard cout package as well, and output those. I recommend that you do print them out with some sort of information that says, by golly, this is the line number and this is the file name that I'm at. But every once in a while, I just litter my code with those because I'm just trying to trace through and see what happened or things like that. And I do this in other languages. I have a package that you can use if you ever end up programming in Go called Go Debug, and it has a function in it. The package is up here. The function is lf, which returns a string with the line number and file name in it. And if you go looking at the documentation on the package, there's a bunch of other stuff that it does that are aids to debugging, but this is my most common thing that I'm adding in, is the line number and the file name. How about JavaScript? This is either Node on the server or JavaScript in the front end. You're building a web application. Here's a function that, yes, there's the function, and here's how you call it with console log, and it returns the line number, which is just useful. Or Python, same sort of thing. I have this function, get line number, and over here, I call it, so that I can actually print out where I am in the code.